So yeah, we're going to be talking a little bit about SBOMs today. And disclosure, no actual dragons were harmed in the creation of this presentation. This one's going to be a fun one, I think, but a little bit about me before we get started. I'm the leader of two flagship OWASP projects. First one is the OWASP Dependency Track project. That's a project that is specifically designed to analyze, analyze SBOMs, software bill of materials. I'm also the chair of the CycloneDX Software Bill of Material Core Working Group, and I'm the leader and the co-author of the OWASP Software Component Verification Standard. It's a way for organizations to measure and improve their software supply chain assurance. I participate in a lot of various working groups, especially for the US government, on software component transparency. And what I actually get paid to do is software security architecture, where I lead a team of architects, where we work with around 4,000 developers, helping the organization create and maintain secure and resilient software. So yeah, we're going to talk a little bit about SBOMs today. And there's most people have an analogy around SBOMs that it's a list of ingredients, right? At its very fundamental level, this is kind of what it is. And as a consumer, this just happens to be a list of ingredients of back of an energy bar. And as a consumer, this allows me to make very basic risk-based decisions. For example, if I'm allergic to nuts, this is something that I might care about. Of course, in the software world, we're not necessarily looking for nuts. We might be looking for the presence of struts, right? Because many organizations should and can be allergic to certain types of frameworks. This talk is not going to be a general purpose SBOM talk. There are plenty of those available. I've probably given upwards of 10 of them this year, but this is a really excellent talk by Dr. Alan Friedman from CISA, as well as Frederick from Anthem. This was over at KubeCon this year, and it was a live event. I kind of missed those. But this is a really excellent presentation if you want to get some background about what are SBOMs and kind of why they're important and why you should care. However, one of the reasons why we all should care, and although this is US specific, the US federal government has an enormous budget for all kinds of things, including software. And when the US federal government says, hey, software vendors, when I procure software for the federal government, and by the way, you have to provide a software bill of material, otherwise we won't actually purchase your stuff, that has a downstream impact. The reality is that none of us are in the at the very edge of a software supply chain. The majority of us are in the middle of a software supply chain. We might produce stuff for external use, but guess what? We also consume stuff from other vendors, from other providers. We're all kind of in the middle. So with the massive budget that the US has, this kind of has a downstream impact on pretty much the entire software industry. The executive order signed earlier this year by President Joseph Biden deferred a lot of the requirements over to NIST, and the SBOM specific requirements were deferred even further to NTIA, who the National Telecommunications and Information Administration, who have been working kind of in this space formally since around 2018 or so. And they created the minimum elements of an SBOM. And so good publication, fairly light read if you want to check it out. But basically, the minimum elements of an SBOM are essentially this: supplier name, what is the name of the component, what is the version of the component, what are maybe some identifiers. And this is more about like CPE or package URL, something that I can used to look up that component in, say, the National Vulnerability Database. My dependency relationships, does my component include something else, or does it depend on something else? Author and timestamp. These are some basic fields that are required for really basic vulnerability management use cases. So if I have a software bill of material for an application in my environment, I will now know if one of the components in that application has a known vulnerability. And I'll have the supplier information so I can contact the supplier for any remediation. Maybe there's a hotfix, maybe there's a patch or an upgrade. So it's really basic vulnerability management use cases. But minimum elements are kind of the first dragon. But again, no dragons were harmed in the creation of this presentation. Minimum fields are going to result in minimal benefit. So what else should we actually care about? Well, here's a few of these things that we should care about: authenticity, integrity verification, services, etc. And we're going to dive in through some of these in just a moment here. And let's start with authenticity. If I have an SBOM, if I'm actually if a customer asks for an SBOM and I give them an SBOM, there's no mechanism for sharing these things today. How does the consumer of that SBOM know that it hasn't been tampered with? And so there's a way to sign, right? We can digitally sign SBOMs today. And so authenticity is one security and really important security use case that we all should care about. Our global software supply chains are under constant attack. And whether it's from inside, SolarWinds, for example, where they actually broke into the build system and did all kinds of things after gaining access to that. So it's kind of important, not just for the transfer between entities, but even signing within the same organization, because you might actually discover an issue that you didn't realize you had if you are signing things and then verifying those signatures throughout your entire process. The integrity verification. If I have a component, has it been modified from its original thing? That's kind of important. Again, the SolarWinds incident, this was actually part of that issue. So in many cases, however, a component might have been modified, and it might have been intentional. Maybe they backported some security fixes, whatever. But in most cases, if you have a mismatch in your integrity, in the verification of that integrity, that's interesting, and it's a data point that, as an organization, you should probably care about. Services. Components, software doesn't live in a bubble. I can't remember the last time I used software that didn't phone home to something, right? That didn't try to automatically update, that didn't rely on some kind of external web service. Services are a very important part of the software inventory and needs to be treated as such. The minimum fields don't account for that. They don't account for services, which rules out a very large percentage of software that's created, and a very important part of software that's created. Services are really important, and we should care about those in our global inventory of software components. Now, in many cases, organizations can and will make modifications to software. In many cases, these cases are typically the result of using a third-party component that might no longer be supported, right? Maybe the project is defunct, or maybe that that branch of that component is no longer supported. But you have tight coupling in your software. You can't automatically upgrade to the latest version. So what is a responsible organization to do? Well, they backport the security fixes, right? And that is part of your component inventory, right? It's interesting information because it tells the consumer that, yeah, I'm actually using this component. Yes, I know that it's vulnerable, but you know what? I'm a responsible organization. I've actually mitigated this particular vulnerability by introducing this code block that fixes the issue. So, hello, Mr. Customer. You don't have to trust me that I fixed it. Here's the evidence in the SBOM. You can verify it for yourself. So, really important use case that really is applicable to many organizations. Now, no software is perfect, right? Every piece of software is going to contain a vulnerability at some point in its life. I'm responsible for, a few CVEs, and I know how to do this. Writing secure software is hard, right? The stacks that we're all given as developers, they're all inherently broken. RFCs are broken. Everything it's challenging. And a tremendous amount of empathy has to be placed toward development teams because they're expected to perform miracles and get it all right. That's just not reality. But what we need to do is, when we're creating our inventory of components, have a reference to a feed for security advisories so that we can get automatic updates on, is this component that I'm using, is it vulnerable or not? Even if that vulnerability is not in a public database like the NVD. Vulnerability disclosure. Now, this is not disclosure in, this word should probably change, but an SBOM that actually communicates the vulnerabilities that this product actually has. Now, most software vendors are not going to do this, right? They're going to communicate the inventory. However, not all SBOMs are going to come from the vendors, right? They might come from a third party who actually audits a piece of software and vets it for approval for a certain environment, right? So it's very important to be able to identify not only the inventory, but the vulnerabilities that inventory has at a specific point in time, because that's really important if you need to go back later for forensic or any kind of investigative purposes. Software is really, really complex. And, Stack Overflow is and services like that are a popular destination for not only developers, but security people and hackers and everybody else. Knowing what's in your software, right? Whether maybe you have a component that you got from a supplier and you don't necessarily know if what else is in their sausage, so to speak. You can specify that saying, hey, I got this component from this supplier, but I don't know anything more beyond that. You can also say that, hey, I've got this component and I know exactly what's in it. And there's all kinds of middle ground in there as well. But software is complex, and even a small little code snippet can wreak havoc to an otherwise, non-vulnerable component, right? Being able to track that vulnerable code and its use across multiple different components. So being able to identify the completeness or the known unknowns is really important security use case. Provenance. Provenance is really about the origin story. This is where we got something from. If there's anyone in the audience that has been reading up on the SALSA framework, for example, that's OpenSSF, their definition of provenance is very, very different than the MITRE, OWASP, and US English versions of definitions of the word. Provenance is really origin. And in this case, origin could be a few different things. It could be the supplier, like a commercial entity where I obtain software from. It could be the public repository in which I got something from, Maven Central, NPM, PyPI, whatever. It could be a country. Maybe I got something from the United States or from Israel or from an adversarial nation state, right? That's really interesting information, especially for FOCI use cases. FOCI, FOCI, foreign ownership, control, and influence. It's a U.S.-centric term, but that concept, all world governments basically have the same concept. So knowing where you got something from is really, really important. Even if you verify it and it hasn't been tainted, just still knowing where you got something from is part of the cycle of trust. Pedigree. Pedigree really refers to the DNA. What is my makeup? What is my lineage of my components? Components, open source software is the ultimate supply chain, right? Components can and will be forked, modified, renamed, redistributed ad infinitum, right? For on and on and on. And being able to identify what your component is and all your modifications that you've made to it so that you can represent your modified version to the world is a really important use case, especially if those use cases involve you backporting security fixes, fixing defects, adding additional features that maybe that component didn't have to begin with. Well, your modifications are part of that component's pedigree now, and you can describe those with SBOMs today. And, security isn't the only use case. There's other non-security use cases out there, including license compliance. Open chain, for example, is relevant in many, many organizations, and SBOMs can be used as a attestation or as a compliance artifact for open chain compliance, for example. And of course, there's many, many more use cases that we as SBOM producers and SBOM consumers should actually care about. Now, when the NTIA, the National Telecommunications and Information Administration, put out its minimum elements, it spec'd out 3 different formats. CycloneDX, which originated from the OWASP work and is now a flagship OWASP project. SPDX, which is a Linux Foundation project, version 2.2.1, I think, is also now an ISO standard. And then SWID, Software ID, was also deemed as a bill of material format, also an ISO standard. The NVD, just a little bit of background, the NVD has been trying to transition away from Common Platform Enumeration, or CPEs, which is used to identify software, and if that software has any vulnerabilities, has been trying to transition away from CPEs, which are deprecated, into using SWID, and we're still kind of waiting. So hopefully that will happen soon. So that's one of the reasons why SWID is kind of included with this. However, not all SBOM formats are created equal. In fact, once you actually get past the minimum elements, format really, really matters. And in fact, the minimum elements are written in a way where technically SWID is not capable of achieving the minimum requirements. I'm not going to get into the reasons why that happened, but I can say that NIST and NTIA are sister agencies, both rolling up to the Department of Commerce. So the only 2 formats that organizations should be concerned about is CycloneDX and SPDX. Now, CycloneDX is specifically designed to be a bill of material format. But what is SPDX? SP, Software Package Data Exchange, I think it's called. And here comes Hazy Dragon. I want to introduce you to Hazy Dragon because Hazy Dragon is a little confused right about now. It's confused because it doesn't know a lot of identity right about now, because it read through this little paragraph on the SPDX specification where it describes asset identifiers and other content believed to be relevant to a package. And that sentence is very, very important because, one, the package doesn't have an identity that actually maps out to a database like the National Vulnerability Database or OSS Index or any of the others, VulnDB for risk-based security. Rather, it uses external references with a belief system. And this is really, really important because the specification is flexible. It allows you to have multiple Maven coordinates, multiple NPM coordinates, multiple package URLs, and multiple CPEs for the exact same package. Obviously, this is not possible in the real world, and certainly you wouldn't want this for a bill of material specification. But a belief is not a fact, and facts matter in a software bill of material. And to provide a little bit of context, and not just for this particular case of just the fact-based approach, let's take a container as an example, but not this kind of container. We want to talk about this kind of container. And inside this container, maybe there's 100 of these. And inside each one of these pallets, I have 1,000 different widgets. And each one of those widgets has one of these. And this tells me exactly what that product is. There's no belief, there's no evidence, it's just a fact. This component is that. The problem with a lot of possibilities is that possibilities are not actionable, right? Possibilities might be good for strategic initiatives across an organization. However, when you want to do impact analysis and vulnerability response, if I have tens of thousands of assets in my environment and I need to very quickly identify which ones are going to be impacted by a potentially vulnerable component, possibilities are not what I want. I want very specific things that my teams are going to have to respond to, and I will prioritize them based on the business risk. If I have to go through a bunch of possibilities, that's going to increase my response time to the point where, is SBOM really going to be beneficial? I don't know. So that doesn't make Hazy Dragon all that happy. His head explodes. But SPDX, and this is not a bash on SPDX. SPDX is actually a really good format for what it was designed to do. But I grepped, out of curiosity, I grepped the words BOM, SBOM, inventory, and materials, and I came across a single occurrence of the word materials, but it was in relation to a data license paragraph. So I still have a question. Maybe you can help me answer it or not. I think instead of looking at the two formats as one or the other in terms of competition, I think we have to start framing it as using the best tool for the job. Now, the hammer was invented 3 million years ago when cavemen decided to attach a stick to a rock. And it wasn't until the 15th century that the screwdriver was invented. Now, did the screwdriver replace the hammer? No. It's a different tool for a different job. And as SBOM creators, as SBOM consumers, we need to choose the best tool for the job that we are doing. And when we are creating SBOMs, there are some hidden dragons in there. So let's find out what some of those are. Now, there's a lot of different ways that we can produce SBOMs. There's probably more ways to produce SBOMs than there are to consume and analyze them, for sure. My favorite way is build time integration, right? I like integrating SBOM creation in the build lifecycle itself. If I can tie onto a package management system like Maven or NPM or any of the other Composer or CocoaPods or whatever the case is, if I can tie into one of those, those package managers, even the quirky ones like Go, they provide a lot of rich metadata about the components that I'm pulling in to my software. And I can use that information in the creation of an SBOM. And this is a lot of data that you don't get after the fact, right? It's very hard to obtain a lot of this data afterwards, right? So integrating into the build has a lot of different advantages. However, there's some, most build systems have a build lifecycle. There's very few that actually just have like a locked file and it's just written in stone, right? They all typically have some kind of variance, and the life cycle actually matters. For example, if you take Maven, who has a very predetermined formal life cycle, its dependency graph isn't fully resolved until certain stages of that life cycle. So if you were to analyze a POM, for example, outside of the build itself, your inventory and your dependency graph would be inaccurate because it didn't go through that life cycle. Likewise, if I'm creating a JavaScript front end, and the most common method of distribution of front ends is typically Webpack or one of the similar types of packing technologies. Well, Node, NPM, is based on a micro module architecture, right? There's modules for everything, but your resulting JavaScript front end is going to have a fraction of the modules that are actually in your lock file, right? Not everything in your lock file actually ends up in your distributable. And if you want to communicate out to a customer what's actually in your software versus what's just in your lock file, those are entirely different things. And you're only going to get that information if you actually integrate with the Webpack process itself. You can't do it after the fact, right? It can't be done. Now, there are some standalone tools that try to do this. OWASP went down this path in 2012, 2013, and it didn't really work all that well. And the idea was to try to just add, this was not the dependency check project, which was very, very good, by the way. Jeremy Long has done a fantastic job with that project. If you haven't checked it out, you should. But we try to create a way to do a elementary bill of material as a universal tool, and it just didn't work for the reasons that were mentioned, right? Build integration, build life cycle really, really matters. The other way you can produce SBOMs is from source files. Now, this is, I think its importance is minimal, but you can create an SBOM from all of your source files. And it's basically, I think you can do it better if you just link to the version control system and specify the commit or the tag, right? To specify the commit or the commit hash, because that's immutable. That's gonna tell you everything you need to know, and you don't actually have to create the source SBOM. So save yourself some trouble, but it can be done. Now, you can also create SBOMs with SCA tools and other types of forensic or audit tools, right? There's many binary and manifest SCA tools out there that can create SBOMs. The interesting thing, and here comes another dragon, the interesting thing about SCA is that they're not designed to identify an accurate inventory. That's not their job. Their job is to identify risk. And most of the time, being close enough is good enough, right? If I'm a minor version off on something, is it still vulnerable? Probably. Is it licensed? Is it still have the same license? Probably. It's usually not a big deal, but SBOM's accuracy actually matters. So that's one caveat. But you can produce them, and it's really, really easy for you to do this today without having to integrate them with all of your builds. If you already have SCA tools in your pipeline, especially some of the commercial tools, those commercial tools, many of them can produce CycloneDX SBOMs today. The ones that can't, you should ask the vendors to support it. Finally, this is one I'm really, really proud of. I never thought it would happen, and I never thought it would happen so easily. But IASP and RASP, as well as mobile, everything runtime, you can actually create SBOMs at runtime while the application's actually running. And that's really interesting. I mean, you're not going to get the build time metadata, that rich data that you have, but you get some really interesting other data, right? You're going to get the components that are actually invoked, right? You can create the full BOM if you want. And you can also specify, hey, this one over here, yeah, it's not really used. So yeah, if you have vulnerabilities in it, it's probably of a less priority for you. But that's a really interesting idea, is be able to see which ones are invoked and which ones are not. The other thing that's really interesting to me is being able to dynamically recognize the services that these components are calling out to, right? And those services can be part of the inventory and then part of the dependency graph. For example, if I have a Java component that is responsible for getting stock quotes, right? It's a convenience library, it's a shim, essentially. It allows me to programmatically get a stock quote without actually having to worry about the REST calls or the HTTP or the TLS negotiation, right? Everything is kind of handled for me by that library. I just have to call, hey, get quotes for MSFT, right? And instead, that component then actually relies on a service, actually handles all the communication, gets the result, returns that result so that I can use it. Maybe it returns a string, right? That service, that component and that dependency on that service can actually be represented in an SBOM. That's fantastic, right? That's something that I really was hoping that we would get to, and we got to it a lot sooner than we thought we would. There's a lot of innovation happening in this space today, but there's many other ways that we can also produce SBOMs today. But I wanted to mention all of this to you because when you start out the path of creating SBOMs, it's really easy to kind of go down a path and not necessarily know that you're kind of on the wrong path and shoot yourself in the foot. So watch out for the dragons and try to use a kind of a mix and match of kind of all the different ways to produce SBOMs. Because if you take some build SBOMs and some SCA SBOMs, I like to use the phrase trust but verify, right? I like to produce SBOMs in my build pipeline and use commercial SCA tools as verification, right? And then the runtime, if you merge all that data in there, you're going to have the most feature-rich SBOM of anyone. And then, of course, watch out for the pitfalls as well. Because if you go down the wrong path, if you, do a source SBOM and think that that's going to help you for, I don't know, vulnerability management use cases, it's not. It's not. It's going to help you for a few, but there's much bigger things that we need to worry about. So the richer your SBOM is, the better data going into it, the better results you're gonna have coming out of it. And I wanted to take a little bit of time to talk about CycloneDX. Yes, there's a couple different SBOM formats. This particular one is coming out of OWASP, and I think it's really important in the security space. So we're going to dive into it for just a little bit. Now, CycloneDX is, there's a huge focus on simplicity, right? We could have created the perfect model, but perfection wasn't our goal, right? We wanted to create something that was lightweight, that would be validatable with XML schema or JSON schema, right? We didn't want to use some weird tools to be able to validate our SBOMs. So really focus on simplicity. But the model itself is also very, very simple. Essentially, your inventory is either a component or a service. And this is by design, right? Because a simple data model allows us to create very simple tools. And very simple tools allow me to orchestrate the creation of an SBOM throughout my entire build pipeline. So instead of thinking about SBOM creation as just a point in time event, hey, I got a piece of software, I'm gonna create an SBOM, boom, done. That might work for a lot of software, but there's also a lot of software in there where that concept just doesn't work, right? You typically want to enhance or correct or modify that SBOM throughout the course of a build pipeline. And once you get to the end, then you can sign and verify that SBOM. And at that point, you actually have something that you can deliver, whether it's internal delivery or external delivery to a customer. But think of SBOM creation as a process. And if you have a very simple tool, or a very simple model, you can have very simple tools and highly efficient tools that can scale to producing tens of thousands of SBOMs per day in a build pipeline without a lot of effort, right? So it's highly designed for automation purposes. The simple model, however, has some really interesting benefits. It's very easy to adopt as well as create new implementations of CycloneDX. The adoption is really about, as organizations, let's just create an SBOM. But there's a lot of tools that needed to be created, right? Yeah, I have a specification, but having a specification that nobody supports isn't beneficial, right? You need a specification that people want to support. And it's really elementary for whether it's an individual contributor or a commercial vendor to read, understand, and create a fully compliant, 100% compliant implementation of CycloneDX in under a day. It's not hard. Now, I mentioned everything was either a component or a service. And there's a lot of different types of components, everything from applications and libraries and frameworks, containers, operating systems, firmware, devices. Yes, we support hardware, a bit not very good today, but that will be improving. Files, and of course, services. The interesting thing about the CycloneDX model is that it's really a BOM format. Yes, it's a software bill of material format, but it's also an operations bill of material format. And OBOMs are actually a BSIM requirement. If your organization is into maturity models, operations bill of material are a requirement for SBOMs, which often vary a little bit from software bill of materials. I might have an application, but you know what? That application is deployed somewhere. Maybe it's deployed to an app server that's then running on an operating system. Well, that would be my operations bill of material, that full stack inventory, right? Manufacturing bill of materials. This is really for hardware use cases, and we're making some improvements in that space. It's not prime time yet, but it will be. And software as a service bill of materials. This is something that CycloneDX has supported for a very long time now, being able to describe our services And in fact, we can describe complete microservice architectures. We can describe services that depend on other services or which include other services. So we can describe a system of systems approach, whether it's microservices, the actor model, or any kind of architectural construct. That's all supported today. The great thing about CycloneDX is that this is not theory, right? This is not something that's new. This is in production at a staggering number of organizations today. An estimated 100,000 organizations are using CycloneDX in production today. Now, the 100,000 number is interesting because it's a big enough number that you can step back and say, hey, you know what? This thing actually has merit, right? This thing is actually being used by a lot of organizations. And if there were problems with the spec, you would have heard about it, right? Bad news travels much easier than and further than good news. So if the spec had problems or whatever, we would hear about it, and we haven't, which is a great thing. But the other interesting thing about this number is that it represents a small fraction of the number of organizations in existence, right? There's millions and millions of organizations. Yes, 100,000 is a great number, right? No doubt about that. But it's a small fraction in compared to where we want it to be, right? So we have a lot of growth potential. So from this is kind of your call to action. Now, the CycloneDX website has a lot of different use cases that's outlined here. We talked about a lot of these use cases, from vulnerability management and provenance and pedigree and all these other cases. There are examples in both XML and JSON on the CycloneDX website. Now, the default view when you go to the website is XML. And I don't want you to think that the spec started out being XML. Our preference is actually JSON. However, JSON, you can't make comments in it. XML, you can. So when you're showing examples for something, it's actually easier to show it in XML because you can have inline comments, multi-line inline comments. And then you can just switch over to the JSON example and then see it and see the JSON representation of that. So check out this page because it's going to give you some concrete examples that are real, right? That you can use today with tools like OWASP Dependency Track and some of the commercial and competing tools that support the consumption and analysis of SBOMs today. The other resource that I want to tell you about is the CycloneDX Tool Center. And the Tool Center is basically a resource to have all the commercial as well as the open source tools that are available in the market. Now these are just the ones that we know of, and I think there's around 85 of them today that we know of. Actually, I just found out about another one a couple hours ago, so I've got to add it today. So by the end of the day, there'll be 86. These are just the ones that we know about, though. So if you come across any others, let us know. Actually, on that page, there's a link at the bottom of the page to the repo, so you can submit a pull request. So if you know of a tool, you can either let us know, or you can just submit a pull request. But it's also a way for if you're a commercial vendor and you want to get acknowledgement, for example, that you support the standard. It's a way to get kind of included in the global list of all known tools. So if you know of anything, or if you have a product in the pipeline that is going to be supporting CycloneDX, I highly encourage you to just reach out or submit a pull request and let us know. We want to provide the community with all the tools necessary so that if they're looking for X, they can actually find it, right? So that's really the purpose of the tool center, is a springboard to kind of get you started. Now, the current version of CycloneDX is version 1.3. And it's a fantastic spec. Lots of contributions, both from individual contributors as well as a lot of commercial contributions that we've had to the spec. Version 1.4 is currently in development, and we're anticipating a release of, I don't know, about the January 2022 timeframe, so not too far out. We are going to be improving our hardware support for manufacturing bill of material use cases, right? This has come up many times, especially in the industrial control system space, as well as the IoT space. The interesting thing about hardware is that they have a long history of using and creating and producing bombs, right? This is not new to hardware space. They've been doing this for decades, and they have their ways of doing things. So it's very advantageous to not necessarily mix and match, right? You typically don't want a bomb that has both hardware and software components. You typically want to separate them. There's a lot of reasons why you would want to separate them, but we will be improving our hardware support in 1.4. Now, as I mentioned, CycloneDX is a bill of materials format, and we can kind of represent almost anything as inventory, including vulnerabilities. So bill of vulnerabilities is going to be a thing. So if you want to communicate just a list of vulnerabilities from one machine to another, you'll actually have that capability. And this is a very common use case, especially across different sources of vulnerability intelligence. We're going to be improving our VEX support. Now, what is VEX? VEX is vulnerability and exploitability. Think of it as the inverse of an advisory, right? An advisory tells you everything that's wrong. A VEX tells you everything that's not wrong, right? I might be using a vulnerable version of OpenSSL, but the way that I'm using it or the way that it was compiled, my application is not vulnerable. VEX is a way to communicate that out, because as an organization that consumes SBOMs, I want to make risk-based decisions. I want to patch the things that actually matter. Now, if an application is using a vulnerable version of OpenSSL, but it's not actually called or invoked, right? That vulnerable function isn't invoked. That's going to take a lot lower priority in terms of my patch schedule than maybe some of my other things that are in my pipeline. So VEX is a way to help organizations prioritize the things that they should care about. We've supported this use case since about 2019. In fact, Sonatype, who's been a really big supporter of CycloneDX, actually contributed to this extension. By definition, XML is extensible. JSON is not. And we've learned a lot about the VEX support that we currently have with CycloneDX 1.3 and lower. And we've made a bunch of improvements. We've rallied a bunch of folks from different cloud providers, different security vendors, etc. We've got a huge amount of contributions just for this one use case, because it's a really important one and we want to get it right. And that's on target for 1.4. 1.4 also doubles as an advisory format, which will be interesting because CSAF is also now a thing. CSAF version 2, which is the Common Security Advisory Framework or format. Framework or format, can't remember. But check it out. That's
2 minutes. Sorry.
Okay, no worries. We're going to be standardizing the release notes, which is something that most software doesn't do today. There's no mechanism to standardize our release notes. Release notes are Markdown or HTML or PDF or Word documents. There's no way to really use that in a machine readable way. CycloneDX is going to change that. So that's going to be really, really interesting. And of course, we're a security standard. So we're going to be hardening the standard above and beyond what it's already at, as well as improving the documentation now that it's not just for a security niche. This is a very mainstream effort now. So here's the links to participate in the community, check out our website. Everything's on GitHub. We have a dedicated Slack instance, independent of OWASP for historical reasons, but we also have 20 plus channels as well. So check out that, LinkedIn and Twitter for social. And thank you so much for listening to me babble for the last 50 minutes. And I promise no dragons were hurt in the creation of this presentation. So with that, I'll open it up for questions. Thank you so much.